Hello, class. How was your holiday? Let's see. So far, we have 12 students attending. Take a picture. Okay. Are you guys able to hear me? Give me some reaction. Yeah, thank you, Leah. Thank you, Miranda. Perfect. Yeah, mine was actually, I just used the holiday to catch up my work. Perfect. Very good. Thank you, Dustin. Thank you, Charlene. Yeah, thank you, Kayla. Perfect. Yeah. So today, based on syllabus, we are going to learn section 3.3. Before this section, in the first section of chapter 3, we have learned measures of center, mean, median, mode, mid-range. Those are measures of center. Section 3.2, we have learned measures of variation, standard deviation, variance, and range. Yeah, those are measures of variation. Today, we are going to learn measures of relative standing. So that's section 3.3. Yeah, what is a relative standing? You must know this kind of standard exam. Let's say SAT, ACT, or GRE, right? Yeah, those standard exam every year, maybe twice a year, has many students attend the exam. so the pool is bigger. The pool is very big. Once you take the exam, you have a score available, and you can say, is this score on the top 50% or on the bottom 50%, or on the top 10% or on the top of 25%? So you concern where is your score stand in the pool. Yeah, all the participants, they have the scores, right? And you can list the scores from highest to the lowest. And where is your score stand at? Where is your score at? So that concern in statistics is about relative standing. Relative standing. Another similar example, let's say your IQ score. Your IQ score is, let's say, is 110. And you concern 110. So in the whole population, yeah. So is my IQ score on the top or on the bottom or in the average, around average? So that kind of concern in statistics, we are measured using measures of relative standing. Relative standing. Am I clear about that? And we are going to learn the following a few measures of relative standing. The first one is called a z-score. Z-score is a lowercase z, lowercase letter z. The formula for finding z-score of a value x in a data set. Yeah, let me complete the definition here, the concept here. So when we say z-score, it's not just by itself. Z-score refer to the z-score of a value, a data value, x in the data set. Yeah, that's the complete sentence, complete concept for z-score. So when we say z-score, there must be a x-score corresponding to z-score. We don't just say z-score. We have to know z-score of which value, which data value in the data set. So z-score of data value x can be computed by using this formula. X is the value you concern. Yeah, where is x standing in the pool, in the data set? X bar here is the sample mean. We know the notation for X bar, right? X bar is the sample mean. if we use the value x to subtract the sample mean, and then divide the difference by the sample standard deviation. We learn this section 3.1. We learn this notation section 3.2. X bar is the sample mean. S is the sample standard deviation. Yeah, we use the measures of center and the measures of standard variation from previous sections here. Okay, so this is the formula for finding the z-score of a specific x value in a data set. In the formula, we use x bar and s. We need to know x bar is the sample mean. Yeah, it's the mean of the data set. S, lowercase s, is the sample standard deviation of the data set. We have learned that last Thursday. Yeah, last Thursday. Okay, so then what does z-score mean? How does z-score measure the relative standing of x? Yeah, z-score here measures the relative standing of x. How does the z-score working to do that, to reach that goal here? I just draw something like this. So let's say the center x bar is right here. Okay, and the value x, your concern is value x. Is this far away from the center? So this is the distance between x and x bar, right? Yeah, that's how far away x is from the mean. And I also get a ruler. This is a ruler, by the way. This is a ruler. Okay, I make it smaller. Imagine the ruler is z. Imagine the ruler is s. Okay, it's not a normal ruler that we have in the real life. This ruler has the length equals s. The ruler has length equals s. S is the standard deviation. Okay, the ruler has length equals standard deviation. So basically, the z-score is to use the ruler, which is s, to measure the distance between x bar and x, to see how many standard deviation of the value x is away from the center. Yeah, if we read the formal definition here, z-score of x measures the relative standing of x. Z-score refers to the number of standard deviations, yeah, plural, sometimes more than one, sometimes below one, yeah, less than one. So z-score measures the number of standard deviations x is above if it's positive, or below if it's negative, x bar. Okay, yeah, this is supposed to be stop here. The sentence is supposed to stop here. And we have a period here. Yeah, we don't rush. Let's take time to understand this sentence, all right? Yeah, z-score is x minus x bar all over z, all over s, sorry. X minus x bar all over s. Okay, it could be positive, could be negative, or could be 0. When will z be positive? You know the denominator s, standard deviation always non-negative, right? Always positive. Yeah, standard deviation always positive. In extreme case is 0, but we don't really worry about that. So denominator always positive. Numerator, in order for z to be positive, the numerator has to be positive. So when x is bigger than x bar, z is positive. That means your value is above average. When your value, the value x is the value that you concern the relative standing of the x in the pool, in the data set. So when the So when your value is above average, bigger than X bar, then your Z value, Z score is positive. When your value is lower, below the average, means average, right? And your Z score is a negative, right? You see that? What if the deviation of your value X, your deviation X away from the center exactly equal to 1 standard deviation, then your Z score would be 1. Suppose, then we would say if Z score equals 1, that means your value is 1 standard deviation above the mean. What if this distance is twice of S, then your Z score is 2, positive 2. That means your score is 2 standard deviation above the mean. It is possible X minus X bar is negative 1.5 S. Yes, then your Z score would be negative 1.5. That means the standing of your value is below average. How much below the average? 1.5 standard deviations below the average. I don't know if you understand what I'm talking about. Give me some feedback, please. If not, I will try to use a different way to explain it. Hello? Let's see. Yeah, we need to understand the meaning, not just know the formula and do the problem. We need to understand the meaning. It makes sense. Yeah, thank you, Leah. So when we can practice some problem and then understand it better. Okay. Just to see the standard deviation as a ruler. So you are using the standard deviation to measure the deviation of the value from the center. Okay. I want more feedback. Are you guys with me? Do you understand what I'm talking about Z score? Charlie say yes. Melinda say yes. Leah say yes. Kayla. Another example? Okay. Let's try another example. Yeah, we can work on a problem. Yeah, we can work on a problem. Yeah, how about let's try the problem and then and then I do this explanation again, try to explain a different way to see if make it better. So in order to do the problem, at least you need to know two things. When we say Z score, it refers to the Z score of a specific value X in the sample. Okay, whenever we have a Z, we always have a corresponding X, with it. Z not just by itself. Yeah, when we say Z score of what? Z score of X. Okay, yeah, that's the first thing. Second thing, you need to memorize this formula. Z score equals X minus X bar all over S. X bar is the sample mean. S is the sample standard deviation. That's the second thing. Yeah, let me add one more thing. Third thing. Yeah, what do we use Z for? Z score of X measures the relative standing of X in the sample. Okay, if you remember that, we can start to practice. Mimi, do understand? So how about let's look at the problem. First question. It's pretty small, right? How are we supposed to remember all of these formulas for a test? There's no way I'm going to remember all of this. So far, we only had one formula. Am I right? So far, we only have one formula. The only one formula is Z score. Z from all the classes. Then let's say today you only need to remember one. Is that not allowed to ask? Is in the syllabus, no formula sheet. The test is a closed book, closed no. You have to figure out a way to memorize. You have to make effort to remember them. If you really understand them, to be honest, if you really understand the meaning, you do need to make too much effort to memorize. You see what I'm talking about? Even if I allowed you, to use the formula sheet, if you don't understand, you still don't know how to do the problem. Trust me. If you understand the concept, you really do not need to make much effort to remember the formula. Okay, let's give it a try. You need a note. No notes. I'm sorry, Mimi. No notes. Okay? No negotiation on that. We agree on that the first class. All the exams are closed book, closed notes. Yeah, number one. Let's look at this problem. If your score on your next statistics test is converted to a z-score, so your score here is x, all right? Your score here is x. We are going to convert your x score to its corresponding z-score. Why? Because from looking at the value of z-score, we would know the relative standing of your score. Okay, which of these z-score would you prefer? We have -2. Let me make this smaller. I couldn't see the whole thing. We have -2. We have -1. We have 0. We have 1. We have 2. And y. Yeah, which one do you prefer? Let me cover my answer here. Too late. Okay, so do you understand the question? Your score in a class is one of the many values, is one value of the data set. Let's say your value is x. So you're going to convert your x to its corresponding z-score. Basically, we're standardizing your score. So do you want the result to be -2 or -1 or 1 or 0 or 2? Let me explain if your z-score comes out as 0. What does it mean? Okay. If the z-score of your score is 0, that means your score is equal to the mean of the class, the mean score of the class. Your score is at the same level of the average. Does that make sense? Okay. 2, yeah, Charlene said 2, because its standard deviations would be above the mean, the best score out of the 5. Perfect. Exactly. You understand it. If you don't understand that, you would not choose the right one. Exactly. But do you understand what I'm saying? When I say if your z-score comes out as 0, that means your score is the same level with the average. If your z-score is a positive 1, that means your score is better than the average. How much better? How much above the average? 1 standard deviation above the average. Standard deviation measures the variation, right? If your z-score is 2, then that means your test score is 2 standard deviations above the means, even higher. You know what I'm saying? But if your z-score is a -1, you don't want to be negative. If your z-score is a negative, that means your score, your test score, is below the mean, below the average. Is a majority of people is better than you. Okay? Yeah, if it's -1, means your test score is 1 standard deviation below the mean. If your z-score is a -2, that's the worst here among those values. Then that means your score, your test score, is 2 standard deviations below the mean. Please give me a response. Do you understand what I'm talking about? Let's go back the Charlene say yes, Dustin say yes. Melinda say yes, Leah say yes. What about other people? You are sleeping? Are you guys not paying attention? How about everybody responds me? Kayla say yes. Atali. Anybody else? Yeah, Madison, Miranda, Natalie. You really understand? I don't mind you say no. I can try again. If I try many times, you don't understand. I'll move on. Okay, perfect. So let's continue. So that is question number 1. Let's do question number 2. For a super tiny. Leah say, I think it will be a bit easier when we can do it ourselves. You want to do it yourself? Yeah, how about let me change this to a similar question. Let's give it a try. How do I do that? A similar problem. You want to try it? Why is it so small? I'll do this. Because you asked me to give you examples, I gave you examples. Let's do one more at least. This is mathematics, but we are learning mathematics in English. You do need to have a good understanding about English. I want you to walk through the steps. Okay, I'll try. I got the first part. It's the second part that is confusing. Which question? Mimi, which question you're talking about? The one we are going to go over? Yeah, let's look at it. Yeah. For a data set. Yeah, let's look at it. I have not read the question yet. For a data set of the pulse rates for a sample of adult females, the lowest pulse rate 34 beats per minute. The mean, okay, so this information tells us the mean of the listed pulse rate is x bar equals 75. So x bar equals 75 beats per minute. And their standard deviation is given as well. S is given 13.4 beats per minute. Part A, what's the difference between the pulse rate? So your x is 34, okay? Even it doesn't say x equals 34, you need to know. You are concerning the value 34 in the sample. So your x is 34. Yeah. What's the difference between the x and the mean? Then you do this, x minus x bar. Okay? And you have 34 minus 75. And what is 34 minus 75? Negative 41, right? Yeah, that part you got it. That's very good. Yeah. Okay, and then let's see part B. How many standard deviations is that? How many standard deviations? So now you are going to use the standard deviation to measure the deviation. What is deviation? This is the deviation. The difference between x and x bar is the deviation. So how do you measure it? You just need to use the negative 41 to divide it by 13.4, okay? All right. Let's see what we have. You have a calculator? The answer, of course, is negative. So 41 divided by 13.4. Hold on. 41 divided by 13.4. I got around equal to, it depends on the rounding. The question will tell you how do you round it later when you go to part 2, part B. Is around equal to negative 3.06. Oops, that means this guy, the pulse rate is very, very low, significantly low. How much lower? How low it is? Like more than 3 standard deviations lower than the average. Yeah, Leah, correct. Very good, very good. Mimi, do you understand that? Okay, perfect. Part C. Convert the pulse rate of 34 per minute to z-score. This is the z-score. This is z-score, okay? So part C actually is the same with part B. Part D, if we consider pulse rates that convert to z-score between 82 and 2 to be neither significantly low nor significantly high, is the pulse rate 34 significant? Yes. If the z-score is bigger than 2, is bigger than or equal to 2, then your x value is significantly high. If your z-score is less than or equal to -2, then your test score or your pulse score is significantly low. This one is significantly low. All right? Does that make sense? Now you know how to do the other parts, right? So not normal rate. Yeah, normal we consider. So when we say normal, we need to have a criteria. How normal? What is defined? How do you define as normal? In statistics, we define if the z-score is between 82 and 2, that is normal. Yeah. Dustin, you make mic is on. Okay. All right. So that is the first measure of relative standing. Yeah, let's look at the formula again to see if it makes more sense now. Z-score refers to the z-score of a specific value, let's say x, in a sample. It measures the relative standing of the value in a sample. And the formula for z, for the z-score, is z equals x minus x bar all over s. When we say standardize a value, we mean we use x to minus x bar and divided by s. That's how do we standardize a value. Why do we need to standardize a value? Because if after we standardize the value and many other values in the same sample, we are able to easily compare them. For example, we have two x scores, and we convert them both to their corresponding z-scores. Yeah, one has z-score 2, the other has z-score -3. Then you would be able to clearly see where they are standing. The z-score, the value whose z-score is 2 means it is 2 standard deviation above the mean. The one with z-score -3 is significantly low, is 3 standard deviations below the mean. All right? Yeah, so knowing z-score could be positive if it's above the average, could be negative if it's below the average. And we use z-score to determine if the value, yeah, I see you say normal or normal, but we don't use that. We use significantly high or significantly low. If it's above 2, significantly high. If it's below -2, significantly low. Then you know where is your value stand at. Where's your value is at, right? Okay, if you guys have no question, we want to move to the next measure of relative standing. I need help with problem 4. Okay, let's go there quickly. By the way, you try not to do the question in the class, okay? I'm just using them as a example. They are all so small. So this is example 4. Consider a value to be significantly low if z-score is less than or equal to 92. Yeah, that's what I just said, right? If it's bigger than or equal to 2, that's significantly high. A data set lists weights of a type of coin. Those weights have a mean and standard deviation. So x bar and s is given. Identify the weights that are significantly low or significantly high. What weights are significantly low? Select the correct answer below and fill in the answer to complete your choice. Okay, I know what you took. I know what is this about. Weights that are greater than. Okay, so you have. Let me explain this way to see if you understand. Okay. So you are given this. You're given this, right? Correct. And you double this, okay? And you find out what is this and what is this. Can you definitely can compute the value yourself, I believe. All right. You compute that value by yourself. Yeah, just charting asked the question. Okay. Let's only answer this question and then move on. Yeah, you answer you get this value. If the value is bigger than this value, is significantly high. If value is less than this value, less than or equal to this value is significantly low. Okay. Yeah, because it's z-score, right? If your score is 2 standard deviation above the mean. Did we learn the range rule of thumb? Yeah. If your score is 2 standard deviation above the mean, or even higher than that, significantly high. If your score is 2 standard deviations below the mean, your score is significantly low. And that's the reason you can have this value. You see that? This value, how do you get this value? You use x bar plus 2s. Yeah, weights that are greater than that is considered significantly high. Oh, sorry. Yeah, what weight are significantly low? So this value is you get this value by use x bar to minus 2s. X bar to minus 2s. Yeah, that's the boundary. Let's say that you determine critical value that you use to determine if it's significantly high or low. Charlene, did I answer your question? Yeah? Okay. So let me move on, okay? Let's move on. The second one, the second measure of relative standing is the percentile. We all know percent is like 100, right? Yes, cent here means 100. How many years in a century? We have 100 years in a century. So here cent means 100. Also, we have 100 cents in a dollar. So cent here means 100. Percentile, whenever we say percentile, we refer to those values. Piece of 1, piece of 2, piece of 3, all the way to piece of 99. Okay, let me explain what they are. When we say percentile, we refer to those 99 values. How do they help us to understand the relative standing? Let's say we have a sample, we have a data set, okay? We put all the data set on the real number line. We have many of them. Some of them bigger than the others, right? Yeah, they are all here. Yeah. So this is the minimum, this is the maximum. Yeah. So we are going to use piece of 1 all the way to piece of 99 to equally divide those values into 100 subgroups. So this is gonna be P50. Okay, and this is gonna be a piece of 1 and piece of 2 and so on and so on. This is gonna be this. Let's say piece 75, and this is a piece of 99. What does that mean? Let's say P sub 50, the 50th percentile. That value divides the whole data set into half, into two parts, two subgroups. And we know, if we know the value of P sub 50, we know around the 50% of the value above that value, and around the 50% value below that value. So that is actually is the median, you know, this actually is the median. Our P50, the 50th percentile, actually is the median. Let's take a P sub 2 as example to explain. P sub 2, if we know the value of P sub 2, we know that value, yeah, in the data set, there's about 98% values above that value, and there are around only 2% below that value. So P sub 2 divides the upper or top 98% and the bottom 2%. Okay, yeah, P sub 1 divides the top 99% values and the bottom 1% value. Is approximately, not exactly. And P75 divided the top 25% and the bottom 75%. And P99 divide top 1% and the bottom 99%. So if your score, let's say take a test score as example, if your score is similar, very close to P99, that means your score is very high. In the pool, only about 1% test takers did better than you. Yeah, around you are better than the other 99% test takers. Do you understand what I'm talking about? So those 99 percentile, P sub 1, P sub 2, P sub 3, all the way to P sub 99, those 99 percentiles divide the data set into 100 subgroups. In each group, we have about 1% of the values, and they are in order. Okay, so if we take a P sub 70 as an example, that means that value divided the top 30% and the bottom 70%. That means if your value is around equal to that means you are on the top 30%. You did better than 70% of the people in the pool. Am I clear about that, guys? Percentile. That's one way to thank you, Dustin. That's one way to understand. Yeah, thank you, Leah. One way to measure the relative standing. Okay, and about this measure of relative standing, we have two types of problem. I'm gonna get one for each. All right. And let's see question number 6 and 7. Let's see questions that we know. Yeah, this is a good one. So we have two types of problem involving percentile. The first type, like this one, you are given a value and you need to find the percentile of that value. You need to use the percentile to measure where does that value stand at the pool. So that's the first type. Okay, let's see how do we do that. Okay, first you see those values. Can you tell me how many values in total do we have here? How many values in total we have? 50. Awesome. Perfect. Yeah. So we have 50 values there. And then we want to see the percentile of 3.3, right? Yeah, where is the 3.3? Right here. Do you see my arrowhead, the purple arrowhead? Yeah. So to find the percentile of a specific value is very pretty straightforward. All you need to do is to find the numerator and the denominator and make a fraction. Okay? Yeah, how do we make a fraction? The numerator is going to be the number of values less than 3.3. Can you tell me how many numbers are less than 3.3? Good news is this data set, even it has 50 values, is already sorted. Yeah, otherwise it's gonna be a pain. Seriously. Otherwise it's really gonna be a pain unless you use the software to sort it. Yeah. Good news is if you look at it, yeah, they are already in order from the smallest 0.2 all the way to the biggest 29.1. Okay. How many values is bigger? Is less than 3.3? 29, correct? Let me see your answer. Yeah, exactly. There are 29 of them. There are 29 of them is strictly is less than 3.3, and we are going to use 29 to divide by the total number of the values in the sample, which is 50. Remember 50? So divide 29 by 50. Yeah, let's see what is 29 divided by 50. You have 58% or 0. Yeah, you have 58%, right? 58%. So we say the percentile of 3.3 is 58. Please do not enter 0.58, or please do not enter 58%. Only enter a whole number from 1 to 100. Okay, you round to the nearest whole number. So 58. Yeah, exactly. Perfect. Yeah, I have the formula right here. Percentile of a value x equals numerator, number of values less than x, denominator, total number of values on the bottom. And then you multiply that number by 100. Okay, make sure you know percentile is not going to be a decimal, super small decimal. It's a whole number. Yeah, don't forget to multiply by 100. Is that doable? It makes sense, right? Yeah, that's where the value 3.3 stands. Yeah. And that means what? That means there are about 58% values below it. Below it. And about 42% of values above it. Yeah, make perfect sense, at least to me. Okay, perfect. Yeah. And the second type of question about percentile is the other way around. What if you already know the percentile? Can you find the value? Yeah. Can you find the value of the specific percentile? Let's find a question about that. Only two types of problem involved for percentile. Let's see what's the number 7 about. Number 7 is the same with the number 6. Number 8. Yeah, this one. This one is giving you a data set. Let's see how many values there. 1, 2. It's the same with earlier. No, it's not the same. 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, oh, 10. Yeah. 1, 2, 3, 4, 5. 50 again. So 50 values again. We are looking for which value. What is the value of the 10th percentile? Where is the value of the 10th percentile? That means which value separate the top 90% and the bottom 10%. How do you get it? How do you get that? We have a formula to that, okay? Yeah, how do you get the 1.7? So again, good news is already sorted, right? Think about the 10th percentile separated the top 90% and the bottom 10%. So we have 50 values altogether, right? In total. So does that mean 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? This value should separate the bottom, actually the average of 0.5 and 0.8 would separate the bottom 20% and the top 80%. You know, the first row, okay, let me put it this way. We have 50 values in total, right? Together, that's 100%, 50 values, yeah. So each row, we have 10 values. Yeah, we have 5 rows in total, so that means every row we have 20%. Do you agree? Every row, we have 20% of the value, right? Did you agree? So this row, the first row, has the lower 20%. And then go up, this is another 20%. Yeah, and then this is the 20% in the middle, and this is another 20%. The last row gives us the top 20%. Do you see that, guys? Yeah, perfect. Okay, but we are not looking for the 20th percentile. We are looking for the 10th percentile. So 10th percentile would be in the middle of the first 20%. What do you think? Yeah, so let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Only look at the first row, the 10 values. What is the median of the first row? What is the median of the first row? Is the average of 0.4 and 0.4, right? Yeah, 0.4. Do you see that, guys? Yeah, perfect. Yeah, you know, if some of the students pay attention, they understand. That means I'm clear enough. Okay, so well, of course, we don't have to always count it, right? We have a formula for that right here. We have a formula for that. L equals K over 100. So 100. So K is 10. Yeah, K is 10. A location. Okay. L here means location. Okay. Let's use this formula. K is 10 because we are looking for the 10th percentile. So K is 10. And N is 50, the sample size. Yeah. So let's get this number as 10, and this is 50. And what do we have? We have 5, right? So we are going to look at the 5th value in the set. That would be the location of the 10th percentile. That would be the location of the 10th percentile. 1, 2, 3, 4, 5, 0.4. Okay? Yeah. Am I clear about those two types of questions for percentile?
So are they always going to be in order, or will we have to put them in order at some point?
Depends on the question. I think what I see from this section, they are already in order. You don't have to do on your own. I have not seen a question need you to order it.
Okay.
Some,
Okay. I
yeah.
thought so. I just didn't know if like on the test it would be something different.
Oh, yeah. Don't worry about that. We will do the review for the tests. Okay, we'll review for the test one. And the other day you asked there's a student asked the time, right? We could even negotiate the time. You want 2 hours, I give you 2 hours. You want 3 hours, I give 3 hours. I don't care. I don't even there. I'm not going to be there. So you want as much as time you want. I give you enough time. Make sure you can finish. You know what? Many students, most of students, they get it done within 30 minutes. And I was surprised. Are you sure you finish? Please double check your answer. They wouldn't do it. They get it done very fast. But you know, I would give you enough time. We'll talk about that when we review for the tests. All right. So any question about percentile? percentile. Okay, thank you guys. Next measure of relative standing is called a quartile. When we say a quarter, 4 quarters make $1, right? Yeah. Quartz. And the other day I saw a guy, he's driving a quartz. Quartz means it has 4 wheels, so quad means 4. And what is a quartile? Let me explain. Very similar with a percentile. This one is just less. You have less. Let's see what's the spell. Q-U-A-R. Yeah, Q-U-A-R. Quartile. Okay, so when we say quartiles, plural, we have 3 quartiles. The notation for the 3 are Q1, Q2, and Q3. Okay, yeah. So we have the 3 quartiles, and then they separate a data set into, or divided a data set into 4 subgroups. In each subgroup, there are around 25% or a quarter of the values in it. Okay, yeah. Actually, Q sub 1 is P sub 25. Q sub 1, the first quartile. Yeah, Q sub 1, you can say Q sub 1, or you can say the first quartile. The first quartile separate the top 3 quarters and the bottom 1 quarter. Same ways, in other words, Q sub 1, the first quartile, separate the top 75% and the bottom 25%. Yeah, you don't want your score, test score close to that because it's on the bottom, right? And you know what? Q sub 2 is a P sub 50 or median. Yeah, the second quartile actually is the median. It is separated the top half, top 5%, the bottom 50%. So 50%, not 5%. Yeah, Q sub 2 is the median actually. It's the same with the 50th percentile, or is the same with the median. They are all the same. Q sub 2 separated the top 50% and the bottom 50%, approximately. Okay, yeah. And Q sub 3, the third quartile, is the same with the P sub 75. It is separated the top a quarter, top 25%, and the bottom 75%. Yeah, so you want your test score closer to Q sub 3. That means you are on the top quarter, right? Top 25%. Yeah, if we understand what is a percentile, we would be able to easily understand the 3 quartiles. Okay? So how do we find the 3 quartiles? If you have a data set, you put them in order. You find the Q sub 2 first. We have covered how do we find the median. Then you know how to find the Q sub 2 because it's the same thing, right? Yeah. And then you're gonna find the Q sub 1. Then you're gonna take the lower half. Yeah. Your Q sub 1 actually is the median of the lower half. Median again. And how do you find the Q sub 3? Q sub 3 is the median of the top half. So you find the median. Basically, you find the 3 medians. Q sub 1 is the median of the lower half. Q sub 3 is the median of the top half. Let's find the questions to practice, all right? Number 9 and number 11. Number 9, number 11. Hold on. Number 9. Okay. So how many numbers here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 50 values. 50 values. Okay. 50 values. That means if we find the 25th value, it's gonna be 1, 2, 3, 4, 5. It's here, right? This is 2.8. Do you see that, guys? 2.8 is the 25th value in the among the 50 value, right? You agree? I wish I can draw something here, How about this? Let me do this. The question asks us to find the Q sub 1 first. Q sub 1 is the median of the lower half. Okay, so we have 50 values in total. Right here, whatever to the left, that's the lower half. Whatever to the right, that's the upper half, right? Do you see what I'm talking about? Yeah, if I do this, those is the lower half. Yeah. From 0.1 all the way to 2.8, that's the lower 25 values. From 3.2 all the way to 25.8, that's the top 25 values, right? Okay, so remember Q sub 1 is the median of the lower half. Okay, lower half. Yeah. So think about if we have 25 values, and the median would be located in 25 plus 1 all over 2, which is 26 divided by 2, which is 13. So we are going to look at number 13, the 13th value. We are going to look at the 13th value. Since 25 is odd, right? Since 25 is odd, we are going to have one value in the middle. Okay, we are going to have one value in the middle. Is that the 13th value? The 9. Awesome. Thank you, Leah. You understand that. Perfect. Very good. What about other people? You don't respond me. Yeah, this is the online class. I don't know what are you doing. Yeah?
Or another way, could you divide 25 by 2 and then kind of just like if the, so like for example for this, the 12th and the 13th number are the same because like the 25 divided by 2 is 12.5. So would you do the number in between those two numbers? Or what would you do? Does that work too?
This formula
Okay.
is certain.
Okay.
We don't change it. Yeah, that's the formula to find the location on the median.
Okay. All right, then I'll use that. Before I realized that, I did that method, dividing the 25 by 2, and just kind of.
So the lower half has 25 values, right? 25 is odd. So we would have one value in the middle. Think about 25 values. Yeah. So we have the value going to be in the middle. There are going to be 12 values below, 12 values above. So it has to be this 20.9. Has to be this one. Okay?
Okay. Yeah, that makes sense. Thank you.
No problem. And guys, can you help me to find the Q sub 2? What is Q sub 2? Is Q sub 2 the same with median? You forget, do you remember what is median? Yeah, 2.8 plus 3.2. What is 2.8 plus is 6, right? Is 3. The median is 3. Do you agree, guys? Yeah. Very good. That's Q sub 2. Yeah. Simply put, what is Q sub 2? Median. Yeah. Thank you, Kila. And how do we find the Q sub 3? Remember, Q sub 3 is the median of the upper half. Yeah. What is the upper half? Yeah. The lower half are the yellow. I don't know if you can see the color. Yeah. All the values before the 28. And I can color the upper half in orange. Yeah, that color is better. In orange, yeah.
Would it be 75 plus 1 divided by 2?
Oh, say again, sorry.
I said, would you be able to find it by doing 75 plus 1 divided by 2?
Where do you get a 75?
Well, Q1, we did 25 plus 1 to get to the bottom 25 percentile. So that's why I figured maybe 75 plus 1 divided by 2 would give us.
No. It is still 25 here is the sample, is the number of values in the yellow. The yellow covers all the 25 values, right? That's the lower half. And here is the sample size. Yeah, we have one sample of size 50. Now we're gonna divide them in half, yellow and orange. We're gonna separate them into two subgroups, right? Yellow and orange. The yellow group has 25 values. So 25 is the sample size. And this formula L equals n plus 1 all over 2 is the formula to find the location of the median. Did I answer your question? Did I answer your question?
Yes.
Okay, awesome. So for Q sub 3, same thing. Okay, because in the orange group, how many values do we have? We still have 25 values. So in the orange group, the median gonna locate at the 13th value. So we are going to look at from 32 all the way to 25.8, and we're gonna count which one is the 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 10.3 is the 13th value in the orange. It means there's 12 below, 12 above, and 10.3 right in the middle in the orange group. So Q sub 3, yeah. Q sub 3 equals 10.3. Okay. Yeah, the L formula is only for the location. 10.3. I hope this is clear. Yeah, thank you, Leah. You're good. You are. It is. Oh, 10.7. Okay, it's 10.3. Yeah. Good news is 25 is an odd number. So the lower half, the Q sub 1, is right in the middle, the value right in the middle of the lower half. And Q sub 3 is the value right in the middle of the upper half, orange. This is a good question. Let me know, am I clear enough? Q sub 1 is, let me write it down. Q sub 1 is not 13, by the way, it's 0.9. 13 is the location of the first quartile. Thank you, guys. Thank you. So that is quartile, right? Yeah, that's quartile. And the next measure of relative standing, another way to help us to understand or assist us to understand where a specific value stands in the sample set is called a 5-number summary. Okay, next one is a 5-number summary. Let me write it down. The famous 5-number summary. Okay, yeah, as the name shows, 5-number summary has 5 numbers. Yeah, what are the 5 numbers? They are minimum. We know how to find it, right? If you have a sample, if you are given a data set, how do you find the minimum? You just look at the smallest value. The least value is the minimum. And then Q1, and then Q2 also is the median, and Q3, and then maximum. Those 5 values are the 5-number summary. Those 5 values are the 5-number summary. Is a summary means is a shortcut, right? So basically, it tells you how does the distribution, kind of like give you the distribution of the data set. Yeah, what's the 2 extreme values? What's the smallest value? What's the biggest value? And then which value is in the middle? Yeah. So how do we which value is right in the middle? And then what's the median of the lower half? What's the median of the upper half? Yeah. So 5-number summary has its graphic version, and the graphic version of the 5-number summary is called box whisker plot. Our book is just called box plot. Yeah, so let me show you how do we graph the box plot by using the 5-number summary. Okay, yeah. So most of the time we do horizontal, sometimes we do vertical. I'll show you in a moment. Yeah, so box plot has a box, right? Has a box. The left edge of the box is Q sub 1. The right edge of the box is Q sub 3. Q sub 2 is somewhere in the box. So that's the box. Whisker. Yeah, the full name of the plot is called a box whisker. You know the cat has a whisker, right? And so these two things like a whisker. This is like a whisker. So this value is the minimum value. Minimum value. And this value is the maximum value. Box plot or box whisker plot is the graphic description of the 5-number summary. It is a better visual aid to understanding the 5-number summary. It's always like that. So for the vertical one would be look like this. The maximum is on the top. The minimum is on the bottom. And the box of somewhere is right here, right? Yeah. The upper edge of the box is the Q sub 3. And this lower edge of the box is the Q sub 1. And Q sub 2 is somewhere in the middle. Not necessarily here, okay? Sometimes yes, but sometimes no. It's somewhere in the box. That is the Q sub 2. I don't know if any of you look at a stock trend, like a candlestick. They not exactly the same, but the idea is similar. The idea is similar. Give me a little bit of time. Let's see. Just similar, not exactly the same. Okay, candlestick graph, stock market image. You see those candlestick? They are similar with the 5-number summary, but not exactly the same, you know. This, for example, this is gonna be the lowest price, like minimum, 2 whiskers, right? And that is gonna be the top, maximum, highest price of that, depending by week or by day or by year, of that day. Let's say day. And then you see the box here, right? You see the box here. We see the candle in the stock market. The terminology is called a candlestick, but in statistics, it's actually the box. Same with our box. And the lower edge of the box is like a. I need to double check. It's been a while. Like a opening price and the close price, yeah, something like that. But Not exactly same, but the idea is similar. Idea is similar. Yeah. Okay. Very good. So that is the 5-number summary. Okay. Yeah. On our MATLAB Math, we have questions to identify. You are given a data set and you need to identify which box plot is the correct box plot that describes the 5-number summary of the data set. And you just need to find the minimum, maximum, right? Find the Q1, Q2, Q3, and to see which one is the correct one. Yeah. One thing I need to point out is in practice, often we have to modify the box plot. The reason is because among the 5-number summaries, we have the minimum, we have the maximum, so they are very sensitive to outliers. Outliers are also called extreme values. Yeah, what is outlier? You probably already seen that question about outliers so far. The outliers of the data set refer to value or values that are a lot bigger than the majority, or a lot smaller than the majority. It's like a sometimes mistake, you know. The reason is more complicated than that. So in practice, very often we have to modify the original box plot. How do we modify? Simply just get rid of the outliers and do it again, right? Yeah, so those are one thing about that here is for the purpose of constructing the modified box plots, how do we determine which values are outliers? Do we have outliers or not? Yeah, outliers are any data values that is above Q sub 3 plus 1.5 times IQR, or below Q sub 1 minus 1.5 times IQR. What is IQR? IQR stands for interquartile range. What is IQR? IQR is the length of the box. The length of the box. That's IQR, or interquartile range. So how do we determine? Yeah, sometimes we need to determine, do we have outlier a lot bigger than the majority, a lot smaller than the majority? Do you have a measurement, do you have a standard that I can determine, do we really have outliers, or which one's outliers? Yes, we do have. We do have the standard. The standard is if the value is bigger than, this is Q sub 3, right? If the value is bigger than Q sub 3 plus 1.5 times of the IQR, is bigger than that value, then we consider that. So think about this is a 1 IQR, and 1.5, this is another 1 QR, this is another half. So it means somewhere here, right? Yeah, somewhere here. If the value is like that, that is seen as outlier. Too much, yeah, too big, yeah. So that is the outlier. Oops, I need to keep, yeah. And the other side, for the small value side, if the value is less than Q sub 1 minus 1.5 times IQR. Yeah, this is a 1 IQR, another IQR, another half IQR. So if you have values less than that, very far away on this end, and that is outlier as well. So that's how we determine, do we have outliers, which values are outliers, and we can remove them, and then we draw another box plot. That is called a modified box plot. Okay, am I clear about that? Yeah, some of the questions in MATLAB Math involve this IQR. Again, IQR is just seems like a very fancy word, but it's just the length of the box. It is just the length of the box. All right. So after we finish explaining this table, if you want, you can take a picture of the table or take a screenshot of the table because it has everything that we need to know. After that, do you have quite a clear understanding about relative standing? How do we measure them? People like to compare, right? So yeah, people like to compare. One thing I don't like about my culture is people like to compare too much. I don't really like it like that. Yeah, people like to compare how much money you make. Do you make more money than me? And so in statistics, that is just a compare of the relative standing. Yeah, this score is to standardize that, then you can compare. Okay, very good. Yeah, so it's close to 50. If you have no questions, we're gonna stop here. And if you have any questions, you can ask, or you can email me later. Sounds good? About the exam one, I mentioned that before. I can repeat that again. Yeah, wait a second. Let me take a picture of the attendance. So let's say one time we're gonna do the test review. Okay, you don't have to worry about which day is the exam one. You don't have to worry about that. For example, today we did the test review. Then after today, after the class, I will email you, and I will tell you in the next week you can go to one of the testing centers to take exam one. So you have the whole week to decide when is convenient for you to take the exam. Something like that. Okay, is that clear? So you decide when do you go. You can go anytime. You have a week to window. Sounds good? Okay, perfect. Yeah. Awesome. Okay, guys, I'll say good night. I'll see you on Tuesday. Bye-bye.